everyone, I'm Martine Visser, Director of the Environmental Policy Research Unit at University of Cape Town. It's my great honor to introduce you today to Professor Michael Hanemann. He actually needs no introduction, especially not from anybody in EfD. Michael has been a very long time friend to EfD, and I must credit Gunnar and Thomas for the amazing ability to bring wonderful people into our circles and inspire a growing network of people and young economists. Before I go on, I just want to make two announcements, and then I want to kind of give you a little bit of background about Michael's journey through life as an economist. Firstly, because it's raining, the bathrooms are through there. And then the other thing is, Alejandro asked me to say to you that the WinEd meeting will be after this, 4 o'clock in the Royal Hall. All good? Great, thanks. So with regards to Michael, when I started looking up what he's done, my head became so dizzy. I mean, if any of you have a Wikipedia page for yourself, you'll know what I mean. It's quite remarkable what he's achieved. But actually, when I was looking through his history this morning, I became very emotional when I saw that he was born in 1944. And the journey that he must have gone through in seeing this field develop, but more than that, seeing the whole world develop. I think at my stage in life, I've often felt myself quite disillusioned and sometimes quite cynical about what we're able to achieve, and sometimes seeing things that's happening in the world. And I think if you were born in the Second World War and you've gone through the Cold War and all the changes in the US and the States, and now what's happening in Russia, I think you've seen a lot, and you've also probably seen what people can do with making continual small changes in favor of the good. And I think if one looks at Michael's life work, there's so much evidence for that. So Michael is currently the Julie Ringley Professor at the School of Sustainability and the Department of Economics at Arizona State University. Can you hear me now? Hello. It's on, but it's not making, yeah, it's not making. Can you hear me at the back? No? Hello? Yes, there we go. Okay, so as I was saying, Michael is Julie Wrigley Professor at the School of Sustainability and Department of Economics at Arizona State University. Before that, he was at Berkeley University for 35 years, and he very involved in supervising students and with projects there still. He's also the Distinguished Global Future Scientist at the Julie Ann Wrigley Global Futures Laboratory. He's a professor at the School of Sustainability at the College of Global Futures. And he's also the director for the Center of Environmental Economics and Sustainable Policy at the Carey School of Business, as well as a member of the National Academy of Sciences. Yeah, the list goes on. He originally he went through his university career from Oxford to LSE, and he did his PhD at Harvard. He was also taught there for a while. And in terms of his membership in organizations, he was, prior to his stint at Arizona in California, he was California Climate Change Center Director for 10 years. And he's also been a member of the Environmental Economics Advisory Committee of the US EPA and lead author of the IPCC Fifth Assessment Report. His publications span more than 50 articles, of which there's the general type articles in AER, and then the more specialist articles in land economics and American Journal of Agriculture Economics. Michael's worked across a very broad span of topics in his career, but he's really made very distinguished contributions in environmental economics to the fields of evaluation of non-market goods, and also with regards to climate change and agriculture, and then also in the field of regulation and policy with regards to water. And it's on that he's going to talk to us today, when he speaks about the economics of water, whether it's too important to be left to economists. So Michael, thank you very much. We look very much forward to your talk, and thanks for being here. So much appreciated.
It's my pleasure. Could you show my slides, please, and I'll walk through them. Let me say it's a great pleasure to be here with many friends whom I've known for a long time, but also this is an opportunity to make new friends. And let me just say I have been very lucky to grow up with environmental economics. The same is true of Thomas and Vic. We happened to be around at the right time, and we were very fortunate. So the title is provocative. So first let me say, in the United States, the economics of water was a big topic in the 1960s, when major decisions were made in the US on water projects in California and the West. Economists lost out in those political battles, and the field of water economics went into a decline in the 1970s. At the same time, energy economics emerged as a field, and all the smart young people went into energy economics. And I was not smart, so I followed energy economics, but when I had a chance to teach at Berkeley around 1980, I started teaching about water economics. If you look now, water economics is taking off as a topic, I'd say, within the last 5 years. And there are many good young PhD students in American universities and elsewhere doing water. But there's a problem. Water, more than anything else, is tied up with institutions, with emotions, with customs. And those affect the context of water. You cannot do a good economic study of anything if you don't understand the context. What is happening is the new generation of water economists that is coming along now generally doesn't know of the context because their professors don't know the context. And so you're having a lot of work that is technically very sophisticated in terms of econometrics, but completely blind to the context. And that's really what I'm getting at. There was a debate, there were papers published in America around 1960, challenged by economists, good economists, but challenging the notion that water is different. And the context was lawyers and engineers who were making water policy would reject economic suggestions, and they'd say water is different. And that irritated the economists, and they said, no, it isn't different. It is different. It still needs economics, but the economics needs to understand the difference. And this is really what I'm saying. You have to you have to go out into the field and understand what is going on before you should offer economic advice. Otherwise, it's a nice theoretical paper, and it's absolutely of no use to anybody. Now, I taught the economics of water to economists at Berkeley for 25 years. And the way I taught it, you know, I'd take a topic like consumer demand, and I'd explain the economic theory, the economic approach, and then I'd apply it to water. But I came to realize that that's wrong. The way I've been teaching it for the last 3 or 4 years is I take a topic and I first describe what is going on the ground, what is happening, how people see things. Then I introduce the economics. But I talk about how the economics needs to be stretched or changed to capture the important details of what's going on. So I want to present the context first and then talk about the economics. And I think as the generation of water economists that's coming needs to see things that way. I'm going to present a number of ideas. I'm fortunate enough to have colleagues, Mehdi Namadi, my student, Jorge, my former student, Philip, and we're testing these things. So I'm going to say many things which are speculations at this point, and we're engaged in the work of testing whether they're true. And if any of you are interested, I'd love to collaborate with you to test those things in your country and your region. I have learned, Dale and I have been friends for 35 years. George Bernard Shaw, in one of his plays, talks about doctors who specialize in diseases of the rich. So I specialize in water diseases of rich countries, and Dale specializes in the water diseases of the poor. I've learned a certain amount, a lot from Dale, but he's not responsible for what I say. And what I know is mainly rich countries. And so some, maybe many of the things won't apply in your countries and will be wrong. I'm doing this because I want to learn about other countries. I want to learn about where I'm wrong. In other countries, I want to learn about where I'm wrong in the United States. And I would like this to become a collaboration to develop a textbook which describes context of what's happening in different regions or different countries, and then links that to the economics. So we could end up ultimately with a sort of multi-version text which applies in different regions. And in some places the economics will be the same, and in others it'll be different because the substance is different. But the notion that there is sort of one economic analysis would be like saying there's one way to treat COVID, and you apply that all over the world to everybody of all ages, etc. That's not right. So there's a list of things I'll go through. And let me just say this. There's a huge discussion of the value of water, and the value of water is very, very large, maybe infinite. But the crucial thing is, water is not a homogeneous commodity. Water at a particular location, when used in a particular way by a particular person at a particular time, is not the same as molecules of water used differently by different people. The chemistry of the water is the same, but the social and economic significance is different. And that makes analyzing water more complicated because it's a much more detailed and disparate subject. That's the point. What I think receives too little attention is the cost of water, how it gets supplied and how much it costs. The value of water is hugely important. The cost of water is hugely problematical. And we tend, in the existing literature, to make mistakes thinking about the cost of water. We think of a cost function. Water as the cost of water supply is a function of the total amount of water supplied in a given year. It's not. Water is more a throughput, not a total annual use of water. It's a throughput. And so it depends on peak capacity, peak hourly capacity, peak daily capacity, peak monthly capacity. Economies of scale are a crucial feature of water. Economies of scale make water so very hard to supply. You have to have the system in place. If you have a network system, you need a source of water, you need an aqueduct, you need treatment plants, you need a distribution system in the streets before you can give anybody a single drop of water. All of that capital is very durable. I mean, we're talking typically 70, 100, 150 years, but it has to be paid for now, even though it'll be benefiting people 100 years from now. If you can't finance it now, you can't deliver the first drop. It's dominated by capital, it's dominated by economies of scale. We tend to confuse time series and cross-section economies of scale. Sure, if you're serving a city of 1,000 people, the cost is very different than if you're serving a city of 100,000 people. On the other hand, if you serve in a normal year 100,000 units, but this year because of a drought you serve 80,000, the costs don't change in the same way. And at times, because they're mainly fixed capital and the capital is fixed. Water is more intensive than any other utility. It is much simpler, it's much cheaper to give everybody, say in Uganda, a cell phone than to give everybody a connection to piped water. Water is more capital intensive than any other utility. The capital is heterogeneous. You know, it's pumps, valves, tanks, dams, big pipes, thin pipes, the whole works. It's sized to meet peak uses. The majority of the cost of water supply in a network system, which is what I'm talking about and which I know not everybody has, those are capital costs. Very good economists misunderstand the costs of water. So if you look at cost functions, everyone I've looked at treats labor costs and material costs as variable inputs. They're not. They're not. You can't substitute $1 of labor for, you know, $1 of pipeline. So here's the thing. Most of the labor is a fixed cost. If you have a drought and you supply less water, you don't fire workers. Yeah, you still have the same number of shovels and all the other materials. In a network system, the only variable costs are chemicals to treat the water, power to pump the water, and if you're purchasing water from a supplier, some of that is a variable cost. But that's often maybe 20%, maybe 10% of the costs of water supply. So we wildly exaggerate the importance of variable costs. And this is having a huge financial implication now. You have a drought. Water use falls by 10% or 20%. Costs don't go down. Or rather, the share of costs that goes down is maybe 10%, and 90% of the costs stay fixed. And the unit cost, the cost per gallon, goes up because the number of gallons went down dramatically, but most of the costs stayed the same. So California experiencing a drought, the Colorado River Basin, you find you're delivering less water, you're telling your customers to save water, and you are charging them more per gallon. Whether the total bill goes up or down depends on how drastically they cut their consumption. This is a political problem, and it's also a financial problem because it wrecks the finances of the utility. This is not realized in the US West or other parts of the country. It's a major issue that's going to come along. So why is this? So when we do cost functions like good economists, we draw isoquants and, you know, with curvature, and we look at input substitution. I think input substitution is, in practice, non-existent in water supply. I think it's probably non-existent in most manufacturing production, and even in chunks of agricultural production. At the level of an individual process within production, sure, you have ex-ante substitutability. You need a pump. There are some pumps which are more highly mechanized, which therefore require less labor, but they have more capital or technology input, compared to other pumps which require more labor, but you know, they don't have the computer capacity. But if you look overall, not at the level of the process, but at the overall system, there's no substitution between aggregate labor input and aggregate capital. You can't, as I say, substitute some hours of labor for having a smaller tank capacity. And therefore, the cost functions that we estimate, like translog, which assume input substitutability, are wrong. The aggregate data may suggest input substitutability. I don't believe that is a reality in existence. So the way we set about analyzing costs, the way we think about marginal costs is wrong, and certainly in a networked system of the type we have in the US or Western Europe. And it leads to wrong impressions. As I say, most of the costs are fixed costs. They have to be financed. They generate economies of scale because they're fixed and they don't vary with output. And we do a lousy job as economists of analyzing this. Also, price setting is different. So there's so many papers, very clever papers which talk about, better pricing of water, and they assume that, if things change, you change the price of water. Because water is so important, there are institutional processes which govern price setting. And typically in the US, prices are set 1 year ahead of time, sometimes 2 years, sometimes 3 years. And the other major thing is price setting is focused on cost recovery, avoiding or limiting profit. So a price increase can be approved only if it is cost justified. And most people, not economists, think of cost as average cost, not marginal cost. You can disapprove of this as much as you like, but you can't ignore it for the purpose of proposing changes. Let me just go back. Obviously, things can be done more quickly in emergencies, but usually it's accelerating a process that's subject to the usual constraints rather than bypassing it. And so saying, well, in a drought, we should raise prices by 25% because that would cut demand back by the price. I mean, if the demand function were true, which I doubt, that would be a correct statement, but it's a useless statement because you couldn't get regulatory approval. In the same way, you couldn't say if there's a shortage of blood in a pandemic, we should use the market to raise the price of blood transfusions to do demand. And that's why water utilities look at quantity restrictions. They're the only acceptable procedure. And whether we like it or not, we make fools of ourselves if we ignore that fact. Now, I have spent my whole career studying demand